Chapter 9. Cloud Computing. About the chapter. What is the cloud? Cloud computing models. Cloud computing benefits. Cloud computing challenges. What is the cloud? Have you ever heard someone talking about the cloud and wondered what it meant? Although the idea is relatively new, it's not too hard to understand. In fact, you have probably used the cloud many times without knowing it. Cloud computing is the on-demand delivery of computer power, database storage, applications, and others. It resources through a cloud service platform via the internet with pay-as-you-go pricing. When you use cloud, your computer communicates with network of servers. Some of the servers are specialized for storage, while others use their computing powers to run application. An application that runs in the cloud is called a web app. Unlike desktop apps, web apps don't need to be installed. You just need a web browser. Google Docs is an example of a web app. In technical language, cloud computing is a computing paradigm where a large pool of systems are connected in private or public networks to provide dynamically scalable infrastructure for application, data, and file storage. With the advent of this technology, the cost of computation, application hosting, content storage, and delivery is reduced significantly. Cloud computing is a practical approach to experience direct cost benefits, and it has the potential to transform a data center from a capital-intensive setup to a variable-priced environment. The idea of cloud computing is based on a very fundamental principle of reusability of IT capabilities. The difference that cloud computing brings compared to traditional concepts of grid computing, distributed computing, utility computing, or autonomic computing is to broaden horizons across organizational boundaries. Quick fact. By 2018, at least 30% of service-centric companies will move the majority of their ERP applications to the cloud. Cloud computing models. Cloud providers offer services that can be grouped into three categories. 1. Software as a service, SaaS. In this model, a complete application is offered to the customer as a service on demand. A single instance of the service runs on the cloud. Multiple end users are serviced. On the customer's side, there is no need for upfront investment in servers or software licenses. While for the provider, the costs are lowered since only a single application needs to be hosted and maintained. Today, SaaS is offered by companies such as Google, Salesforce, Microsoft, Zoho, etc. SaaS. Highly scalable internet-based applications are hosted on the cloud and offered as services to the end user. Google Docs, Acrobat.com, Salesforce.com. 2. Platform as a service, PaaS. Here, a layer of software or development environment is encapsulated and offered as a service, upon which other higher levels of service can be built. The customer has the freedom to build his own applications, which run on the provider's infrastructure. To meet manageability and scalability requirements of the applications, PaaS providers offer a predefined combination of OS and application servers, such as LAMP platform, Linux, Apache, MySQL, and PHP, restricted J2EE, Ruby, etc. Google's App Engine, Force.com, etc. are some of the popular PaaS examples. PaaS. Here, the platforms used to design, develop, build, and test applications are provided by the cloud infrastructure. Azure Service Platform, Force.com, Google App Engine. 3. Infrastructure as a Service, IaaS. IaaS provides basic storage and computing capabilities as standardized services over the network. Servers, storage systems, networking equipment, data center space, etc. are pooled and made available to handle workloads. The customer would typically deploy his own software on the infrastructure. Some common examples are Amazon, GoGrid, 3Tera, etc. IaaS. In this pay-per-use model, services like storage, database management, and compute capabilities are offered on demand. Amazon, Web Services, GoGrid, 3Tera. Enterprises can choose to deploy applications on public, private, or hybrid clouds. Cloud integrators can play a vital part in determining the right cloud path for each organization. Public and private clouds. Private cloud. Private clouds are built exclusively for a single enterprise. They aim to address concerns on data security and offer greater control, which is typically lacking in a public cloud. There are two variations to a private cloud. On-premise private cloud. On-premise private clouds, also known as internal clouds, are hosted within one's own data center. This model provides a more standard-sized process and protection, but is limited in aspects of size and scalability. IT departments would also need to incur the capital and operational costs for the physical resources. This is best suited for applications which require complete control and configurability of the infrastructure and security. Externally hosted private cloud. This type of private cloud is hosted externally with a cloud provider, where the provider facilitates an exclusive cloud environment with full guarantee of privacy. This is best suited for enterprises that don't prefer a public cloud due to sharing of physical resources. Public cloud. Public clouds are owned and operated by third parties. They deliver superior economies of scale to customers, as the infrastructure costs are spread among a mix of users, giving each individual client an attractive, low-cost, pay-as-you-go model. All customers share the same infrastructure pool with limited configuration, security protections, and availability variances. These are managed and supported by the cloud provider. One of the advantages of a public cloud is that they may be larger than an enterprise's cloud, thus providing the ability to scale seamlessly on hybrid clouds. Hybrid clouds combine both public and private cloud models. With a hybrid cloud, service providers can utilize third-party cloud providers in a full or partial manner, thus increasing the flexibility of computing. The hybrid cloud environment is capable of providing on-demand, externally provisioned scale. The ability to augment a private cloud with the resources of a public cloud can be used to manage any unexpected surges in workload. Enterprises would need to align their applications so as to exploit the architecture models that cloud computing offers. Some of the typical benefits are listed below. Quick fact. Experts predict that 40 zettabytes or 40 000 000 000 000 000 000 000 bytes of data will be held in the cloud by 2020. Cloud computing benefits. 1. Reduced cost. There are a number of reasons to attribute cloud technology with lower costs. The billing model is pay as per usage. The infrastructure is not purchased, thus lowering maintenance. Initial expense and recurring expenses are much lower than traditional computing. 2. Increased storage. With the massive infrastructure that is offered by cloud providers today, storage and maintenance of large volumes of data is a reality. Sudden workload spikes are also managed effectively and efficiently, since the cloud can scale dynamically. 3. Flexibility. This is an extremely important characteristic. With enterprises having to adapt even more rapidly to changing business conditions, speed to deliver is critical. Cloud computing stresses on getting applications to market very quickly by using the most appropriate building blocks necessary for deployment. Cloud benefits. easily upgraded, productivity anywhere, off-site data storage, no IT maintenance costs, disaster assistance, lower cost of ownership, always up. Quick fact: it's predicted that 78% of US small businesses will have fully adopted cloud computing by 2020. Cloud computing challenges. Despite its growing influence, concerns regarding cloud computing still remain. In our opinion, the benefits outweigh the drawbacks and the model is worth exploring. Some common challenges are: 1. Regulatory and compliance restrictions. In some of the European countries, government regulations do not allow customers' personal information and other sensitive information to be physically located outside the state or country. In order to meet such requirements, cloud providers need to set up a data center or a storage site exclusively within the country to comply with regulations. Having such an infrastructure may not always be feasible and is a big challenge for cloud providers. With cloud computing, the action moves to the interface, that is, to the interface between service suppliers and multiple groups of service consumers. Cloud services will demand expertise in distributed services, procurement, risk assessment, and service negotiation, areas that many enterprises are only modestly equipped to handle. 2. Management capabilities. Despite there being multiple cloud providers, the management of platform and infrastructure is still in its infancy. Features like auto-scaling are a crucial requirement for many enterprises. There is huge potential to improve on the scalability and load balancing features provided today. 3. Data protection. Data security is a crucial element that warrants scrutiny. Enterprises are reluctant to buy an assurance of business data security from vendors. They fear losing data to competition and the data confidentiality of consumers. In many instances, the actual storage location is not disclosed, adding on to the security concerns of enterprises. In the existing models, firewalls across data centers owned by enterprises protect this sensitive information. In the cloud model, service providers are responsible for maintaining data security and enterprises would have to rely on them. 4. Data recovery and availability. All business applications have service-level agreements that are stringently followed. Operational teams play a key role in management of service-level agreements and runtime governance of applications. In production environments, operational teams support appropriate clustering and failover, data replication, system monitoring, transactions monitoring, logs monitoring, and others, maintenance, runtime governance, disaster recovery, capacity and performance management. If any of the above-mentioned services is underserved by a cloud provider, the damage and impact could be severe. Let's recall. In Software as a Service (SaaS) model, a complete application is offered to the computer as a service on demand. In Platform as a Service (PaaS), the platform used to design, develop, build, and test applications are provided by the cloud infrastructure. Cloud is a network of servers. An application that runs in the cloud is called a web app. Google Docs is an example of a web app. When you use cloud, your computer communicates with network of